So this is my presentation for my role as the embedded co-op for this term. So I'll cover mostly the design of experiment work that I've been doing, which includes mostly the test jig, but I'll also touch on the other work tasks that I've done, like product management and POC and UBT testing, as well as just a final page summarizing where you can find information on the things I've done. Yeah, so the primary project that I worked on is the design of experiment. Basically, we wanted to experiment with different parameters like temperature, mixing speed, airflow, and ozone concentration in order to find the values of those that made the best quality compost. So I was in charge of assembling and making sure that this project
You see how clean that desk used to be?
making sure the assembly got together. So there's two parts to this. There's the 2 chambers that we started out with, and then next we're moving on to the 9-chamber assembly for the actual DOE. I assembled the mechanical and electrical test jigs along with help from the team, like Chris. Assembled a lot of the mechanical jigs in the first.
That's Chris.
Yeah, that's me.
I also helped out on implementing some of the embedded functionality to the microcontroller, like temperature sensors and control loops, along with Brian and Nipkin.
That's Brian.
Wow. And just testing the chamber sensors and actuators and giving feedback on the chamber design for the product team. So this is the first setup all put together. So there were quite a few issues that came up during this process. I'd say something that caused a lot of issues was circuit board debugging. So this is the box that I worked with for a few months. There's a lot of testing and switching out broken components, accidental shorts, and bad connections that were very time consuming to debug. So we decided that for the next stage of the test, we would make a PCBA. Other issues that came up were motor coupling. Failed quite a few times. Broken shafts from the first gearbox design, then cracking in this design, and finally we settled on the simplest coupling design, designed by Hawaii. And I had to do a lot of testing here, especially with load. There was also the AC versus DC motor load testing. So we wanted to switch from AC motors to DC motors in order to better control the rotation speed of our experiments. So in order to make sure that the DC motors were strong enough, I had tested with the mung beans over the course of a few weeks to make sure that it could rotate at the speed we wanted. I don't know if you've seen the huge bin of beans in the office. We're very fond of it. And finally, another issue that came up was the analog sensor testing. We concluded that because of drift and because of because the sensors weren't calibrated, that we would need to find
Ditch
a
them.
better option. Sorry?
Ditch them.
Yeah, find a better option for the 9-chamber test. Yeah, so basically as a result of assembling these chambers, we could improve on the motor coupling, hardware like the sensors, electronics board, as well as pedals. So this served as a really good foundation for the 9-chamber test. For these, I was also responsible for assembling and designing some of the test jigs, as well as verification testing for all the components, making sure everything worked, and finding the dynamic ranges of all the actuators. So here we could see this is the design that I made for the new frames. I got very familiar with FreeCAD during this time, so I made a little foot for the chamber to fit onto, as well as the motor rig to hold the motor down to the frame as well. And another big issue that came up during the 9-chamber test is testing the PCB heater. So this PCB heater was also used for the actual product. So these were, we decided that they weren't strong enough for the DOE and product purposes. As you can see, it maxed out at about 50 degrees. So the next step would be to test the new AC heater in more detail. Actually, earlier this afternoon, I tested it and it took about 2 minutes to get to 60 degrees, so it's looking pretty good.
Which AC heater?
The one that Evgeny just ordered.
Oh,
Yeah.
nice.
So it's promising. Yeah. So the results of this part of the project, we have one fully functional chamber with the motor, heater, fan, lamps and sensors, as well as 2 of these frames built to hold 3 of the chambers. As for the next steps for the DOE, the assembly needs to be completed. There's more details in the issue list, but essentially the pedals need to be assembled onto the shafts. The motors need to be prepared, as well as the cables. But there's a long list of things, so I'm not going to go into all of them. I think more testing with the heater should be done to ensure that it's suitable for our purposes. I think that the sensor data should also be sanitized. So I mentioned earlier that I had made a table with all the calculation adjustments for gas readings. And finally, I think I should just try the setup at the MedTech lab. I think that would be really exciting to see all this hard work put together.
Yes.
Especially the ozone vent testing would be very beneficial to test there. Yeah, so that's it for the DOE. The other work tasks that I worked on were product management, specifically for the user journey. I worked on with Andy. So this was intended to map the user's actions, thoughts, needs, and pains while they interact with the product. So from the first time they see an ad to the moment they throw out the product or until its end of life. So this still needs to be validated with a focus group, so that would be my next recommendation, to review the user journey and get more eyes on it. Other product management tasks I work on were user flow diagram. So this also helped determine the logic for the product's LED indicator for the everyday routine and the weekly routine. Although the failure flows still have to be completed, and I also think that the focus group, or it should be also validated with potential users as well. And then finally, I conducted a lot of miscellaneous testing. So for example, the chirp sensor that we were planning to use for the level detection for the liquid chamber, as well as helping out with the first flower mesh assembly testing and the EVT heater test. And so the next steps for the team, you can find the information about the test results that I worked on in my to-do page under documentation. So I marked the priority of those that I think would be useful to the rest of the team. These ones are mostly for things that we aren't using anymore or already documented in design of experiment plan. Yeah, you can find most of the information here, or I'll still have access to the Slack channel, so if there's questions, you just message me, and yeah, that's it.
Ooh, nice. Very cute.
Yeah, thank you for a great term. It was great to work here. And these were...
Is that a sunflower? No.
I think it's a daisy.
Oh, daisy.
I've been taking a lot of nature walks, and I found...
Oh, you took these?
Yeah, I took these. Yeah.
Oh, that's cool. $80.
Yeah.
Nice.
I thought it'd be fun.
Oh, it's actually 7 spot, $80. 1, 2, 3, 4, 5, 6, 7.
Yeah.
Huh. Is it the same one?
It's the same bug.
No, it's different. Or well, it's the same species. But
Yeah.
in different places.
That's cool.
Yeah.
Cool. Okay, thank you so much, Kate. Any questions for Kate from the team? Chris, Brian, Satya,
Okay.
Andy? How do you guys like working with Kate?
Great.
Officially, right? Officially. Okay. What's the most impressed thing about her that you found working with her? Memorable things.
Her, like knowledge of the STM code. I remember when I was first learning about it, I asked you a lot of questions and you knew a lot about it. And I was like,
Oh, really?
damn, she's good at this. I was like,
Oh.
Very friendly, kind, and very patient.
Mhm. Yes. How about, what do you think? I know you just had one meeting, so yeah. Great. Yeah, good work, Kate. I think it's pretty thorough what you put down on the slides. How do you find this term? How do you like working in this ambience?
Yeah, I really enjoyed the team. I think it was very open. It was really easy to just
Chill.
ask for help.
Oh.
Yeah, if I needed it.
So, what do you think we did well, and what do you think we could do better?
Yeah, I think I. mm. I think that.
It's okay. You just said we're open, so say whatever. We don't care.
Yeah, no, I
Yeah.
just need to add a second. I'd say that it's really fast paced, and I think that's really helped me get a better work ethic, I suppose. I enjoyed, I don't know, always having something to do. I think that
Oh, you're gone. Okay, bye, Satya. You gotta do one of those days, okay?
Yeah.
Okay, yeah.
Probably next week.
Yes, next week. Okay. See you.
Yeah, I think maybe things we could improve on. I kind of agree with one of the points that you had mentioned during your presentation, Brian. That was
That's Brian.
that the requirements for some things came a little late, or some things were confused. So I think there's a communication issue for starting out tasks, I suppose. But I guess it's hard to avoid given that there's a lot of moving parts. So I can see that.
How could we do better?
How can we do better?
Improve? Yeah.
Yeah. I think honestly, I think having better written communication is like a good first step. I always like to write everything down.
Yes, I agree. Yeah.
So
Document the important things.
yeah, and make sure I don't know, everyone's on the same page about
Yeah.
priorities.
Yes. I agree. Awesome. What are you up to after this is your last co-op? So,
Yeah.
gonna be school for another maybe 2 years? Oh, well, I'm sorry, 2 terms.
Oh yeah, 2 terms.
Okay. So, are you up to anything other than school?
Other than school?
Looking for a job or going to grad school? What's your plan?
Yeah, I'll probably be looking for a job after school. I also, outside of school and work, I just want to get more creative. I just want to like get into more of my hobbies.
Nice. The Illumina project.
Oh yeah. The little
More artistic creations.
yeah, the little tech art project that I did.
That's cool.
Yeah, I might work on that as well. That's pretty
Awesome.
yeah.
Awesome. Thank you. Okay, it's a pleasure to have you. I think everybody loved working with you. Medora loved you. I could tell. I didn't confirm with him, but every time he sees Kate, he's like, oh, very happy. So, yeah. Great. Thank you so much, Kate.
Yeah, thanks.
Thank you.